All right, so in this video, we're going to show you a couple instances of what you're going to run into when you're trying to auto-tune and some of the common faults that you get. Now, let's go ahead and take out this section of logic, put the standard PV in, and we'll take out the actual CV that we have right here and put it back to what it's supposed to do. Let me show you the very first thing you're going to run into. Okay, you see this thing actually working right now. You can see it's trying to move everything to set point. Right, now keep in mind, if you come in here and you're in, and you for some reason you want to auto tune and you're saying, okay, I just want to get a little bit better. If the PIDE loop is in auto, you're going to have to manually tune it. Okay, just keep that in mind. You'll have to manually tune these features. Now, to also get through to this, you can see that coming into the parameters. Now I'm still in edit mode right now, but if you want to see more or less things over here on the sidebar or even on the discharge, you can come over here and put that in there. So you can see the things that I have checked right now. Prog auto, prog man, right there. Prog auto, prog man, and I'm using the prog. I have that there. Now if I wanted to throw in cascade or operator, I could do that. I could just put that in there just like that. Again, move this down so that it matches up. Now that's the only downfall to doing that. If you add something, just make sure I like to make sure everything's nice and lined up so it's easy to read. Okay, so if your system is in auto and then you come over here to auto tune and you have the first you have to acquire the tag, and you have to be in pressure, right? Or let's just say for our instance we're doing pressure, but you can go to temperature, pressure, flow, level, position, whatever you want to go. Your CV, your PV change, I usually set that to anywhere between 25, 50, or 100, depending upon if I want to kind of limit the PV change on the tune. I start out with about 5% CV change. CV change is your CV change up here. Keep that in mind. And then, so at this point, we'll go ahead and we'll try to tune it. And you can easily see the fault says a tune fault, and the mode is invalid. Why is the mode invalid? Is because we are in the actual auto mode, right? We're in auto tune, or we're in auto mode for our PIDE, right? So you can't, that's number one thing that I see happening, that people see, they try to do. You cannot tune a loop, we cannot auto tune a loop if you do have it in auto, the PID loop itself. Most PID loops are generally, actually all PID loops in my opinion, should be in a periodic task, and that periodic task should be whatever it's set to get the outcome that you're trying to get. Now, another thing too I want to kind of highlight is the auto-tune tag. From version 33 to version 36, Rockwell has a separate license you have to buy to be able to use the auto-tune. So if you're in that range, just know you have to reach out to Rockwell, buy the separate license, install it on your computer, and you're good to go. 32 and below, you do not. The auto tune is still part of the process, so don't worry about that. Moving forward on 37, I have talked to tech support, and they said they are completely getting rid of the auto tune altogether, but they do have an alternative software that you use that already works really well with actually integrating with Rockwell, but not to get too far into that, because again, that's looking into the future. What we want to do is now continue our talk on the actual PID tuning. So let's just go in here and see. Right now our PV is changing. Okay, so let's go in here and see if we can't tune it the way it is. All right, so let's go in here and we'll go in here and try to tune again. Or it says in process, okay, and you can easily see that it's trying to do something, right? And it actually come up with a tuning. So sometimes your loop, if it's changing too rapidly, it won't have this effect, right? So this is pretty strong. So let's actually show that again. And let me change my variable so that it is not 3.5 seconds. Let me go to 1 second. So this is going to change every 1 second now, just keep in mind. And let's try to auto tune again, because a lot of you guys are going to see this, and I want to show this. So right now the PV is changing, and it's going to say auto tune fault, PV not settled. Well, so at that point you just need to make sure your PV is settled, and then you should be able to carry on to the auto tune. In the event of most process loops are going to be well over 3.5 seconds, right? They just are. Most process loops are going to, the reaction time of the device or whatever is going to be pretty slow. Now it may be bouncing around a little bit and stuff like that because it's, you know, it's an input value, generally speaking. In this case, it would be pressure. It would be a pressure device that could be bouncing around a little bit. But let's go ahead and tune this again. We can go through and leave the parameters exactly the same and see if we can tune it again. Again, I've changed that process change, and it still says a tune fault. Now, why did it say that? For one, is the PV is traveling down. It's going downward, and the PIDE auto tune expected it to go up. Okay. So in this case, and I'm just simulating this, right? In this case, I'll just basically change this bit to move up, go over here, go back to my auto tune, and then auto tune again, and then let the process finish out. Now again, this is going to settle just enough. Actually, it's not. So sometimes you're going to win, sometimes you're going to lose on this PV, auto tune PV not settled, right? So sometimes you're going to win, sometimes you're going to lose, and that depends on your process variable, right? So let's just say I put this at 5 seconds. That should be more adequate time. There's also another thing down here I use is dead time lead lag, and you'll see that as well too. So let's start and see, because again, honestly, we got lucky on the first time, and you can see the PV not settled is generally what you're going to get if your PV is not completely settled. How do you get around that? Make sure your PV is settled. So whatever you have to do, maybe put a lead lag in front of the PV or something. I mean, because that, if we did that, then that could help out as well. So let's actually try that. So we have a lead lag down here. I'm going to separate that. I'm going to bring it up here. I'm going to come over here to my set point. I'm going to take my set point back. I'm putting in a lead lag. Okay. This is a lead lag, and what it's doing is it has parameters in here. The lag is 4 seconds. So that's going to be a 4 second lag on top of the already, 5 second change we have. Now, again, we're moving downward. Let's change this so that it's a 0 and that we are moving upward. So you see that it went negative right there because, okay, so now we're moving upward. Now we have a lead lag in here. Let's assemble this. Let's go ahead and come over here and see if we can auto tune from here. So we're putting more time in our process change. If I'm saying anything, I'm saying we're putting more time in our process change. Therefore, the change is somewhat settled. If that makes any, if that really kind of closes the loop for everybody, just keep that in mind. PID loops are all going to be different. Not one is going to tune the same as the other one. Okay, they're just not. So just keep that in mind as well. And it says it's still in process. So It did change the PV. It changed the PV to 5. Okay, so it changed the PV to our step size of 5%. And it's trying to make this settle out, right? So it's trying to change this variable and then get its final outcome. What's probably going to happen in this case, because we have 9.5 seconds of dead time, is probably going to come out and, you know, basically say timed out. Now we can wait for that to happen, or I can show you the alternative to what I do is I abort and go over here. I change and put my, let's go back to edit mode. I put this in here and I go to the back side of my dead time, and my dead time, to make this even a little bit more different, I put my dead time in there. So essentially this should look like this, right? So you have your dead time, which my dead time is going to be 5 seconds, and my lead lag is going to be 4 seconds. Let me show you how that works. Okay, so we're in the proper mode. We have PIDE and manual mode, not auto mode. The process loop, you can see, is settling out to complete 0. The dead time, what it does is it does not allow that process variable to change or to move through that instruction until the time that you set is done. The lead lag works a little bit different. When you're using a lag, it takes what you put in it, like say you put in 5 or 10 or whatever, it's going to incrementally get to where that point is. So that's why these are so powerful in loop tuning. All right, so let's go in here. I want you to see all this, so we'll go to tuning, and then we'll go to AutoTune, and then we'll start. So we're in the proper mode. We have, and I want you to see this too, our CV will change. The time, you know, it hasn't traveled through the dead time yet. Now it traveled through the dead time, and now it's traveling through the lead lag, which is, you know, obviously getting to that point. So it did come up with a very fast response, or actually 3 responses: slow, medium, and fast. I generally like to go with medium. That's just me. Depends on, again, every PID loop is different. It depends on what PID loop you're trying to tune. Now, to keep and make sure that this is working correctly, let's go ahead and put a 1 in there, and let's see this try to get to set point. Now, effectively, this right here is our set point, 50 or 45, right? That's our process set point. Our operator process set point is 45. So it's going to try to open up and achieve that goal of getting to 45. You see it's kind of slow, but if we open up the trend, we can see that it is working itself up there. And don't worry about this top line. That is the blue line right now is the actual process variable. We're not using that right now because we just have this in here. So the set point, again, is really where you're trying to go. And this is tuned so slow that it's just taking forever to get there. With that said, let me make sure there's no limits in here. Oh, then that's our problem. So max is 100, and we're going to call set point 100, and then we should see some good results from that. Okay, so it is not changed. The loop is tuning, it's growing. So keep in mind too, the limits are part of your process too when you're setting up a PID loop or PIDE loop and Studio 5000. Now I'm showing you a lot of different things because I'm trying to retrofit this code and kind of show you the things you're going to run into when you're trying to do tuning, or things you need to understand when you're dealing with the PIDE. Just keep that in mind. So you see it's traveling up now. If we look at the trend, you can see that it's still traveling up. Now that spike in there was probably the instance where I changed the set point, or I changed the limits inside of the PIDE. So just keep this in mind. This is going to go, and the blue line doesn't matter right now because the blue line is going to be this process, this simulated pressure right here. I don't have that in play right now, so that doesn't matter. What is in play is this should hit 45, okay? So when this planes out, it should hit 45. It should not, so right now it's currently at 38. As soon as it hits 35, it should settle out, not overshoot, and it should be nice and slow. That's going to be that medium tuning I talked about. Slow tuning would be even slower. Fast tuning might overshoot one time and then kind of settle out. But again, that all depends on how your PIDE process loop looks, right? All the physical devices you use, all the timing, the latency of timing, I should say, and then the way it's set up inside of your actual ControlLogix. You know, with this, in my case, being 100 milliseconds in the scanning rate of the PIDE loop. So we're getting pretty close to our set point. You can see it's still traveling. It's not as quite as aggressive, but you can see it's traveling. So it's somewhat, if I can explain this, what it's doing is it has very little proportional. So it's using a lot more movement from the integral, and then it has derivative to kind of put the brakes on things a little bit. So let's see that. So we're getting right at the point where we should be. And we'll let this hit 45 and then settle out. Now, as soon as this does this, we can put our process variables back. We can put everything back in our controls and have everything work just as they're designed, right? So just keep in mind, I'm using simulation versus actual process variable, right? Because sometimes you're not going to win when you do the PV, and you're having that PV settle thing. And I showed that. So the goal behind that was to, you know, obviously show the process and show how that equation works, right? It also depends on if you're derivative or, if you're dependent or independent, the way your PIDE loop is set up. We are approaching our 45. So for 44.5 right now, you can see that it's not going to overshoot, and it's slowly getting its way to the next, it's 48 right now, or 44.6. So you can see that it's nice and subtle. Now if we change that to fast, again, all we have to do is open up AutoTune, set gains, change that to fast, and now our tuning loop is a little bit faster than what it was before. Not too much, but it is. And then we come over here, we can see it's still pretty stable. I mean, it's not aggressive at all. So as soon as we hit 45, it's not going to move any further. We've hit our set point. If we do change our set point, it will travel down, and then that shows again that same aspect. So I do all my testing like this. I do all of my, just to get a base understanding of, you know, how PIDEs are working, so that when I go out in the field and I work on something, that the PIDE, I understand the process loop itself, the hardware, the latency behind it, and the way everything is set up. That's what you need to understand to get to this point. That's what you need to understand to be successful. You don't have to worry about both sides of the field. You have to worry about just, okay, I know how to make the instruction work, and now I just need to focus on the field, right? Now I just need to focus on the process variable I'm trying to tune, and then at that point, go after that. So you see we're at 44.97, and you can see that right here, 44.97. It's still incrementing up, but very slowly. So let's throw a little loophole in there. Let's go 40 as our new set point. Okay, so 40 is our new set point, and it's going to travel down. It's going to track down to the exact set point that we have. Again, the blue line can be eliminated because we're not using that yet. But as soon as we see everything get to the point where we want it, again, this is 42, and it's going to go to 41, and then 40. We can put everything back. So just keeping that in mind, right? Okay, so we're at 41. And I could have tuned this a little bit faster, but just keep in mind most process variables, most processes itself are going to be nice and slow. They're not going to be fast. So if you want them to be fast, they're going to kind of overshoot and be erratic and stuff like that. So just keep that in mind as well. That's just principles behind tuning a PID loop. So you can see that we're right at 40, right in our set point. Our set point's 40. It's still traveling down, and it will hit 40. We've effectively tested everything though, so let's take out the simulation logic and let's put the natural process loop in here. At this point, everything should work accordingly, and you should be very close. If anything, you need to manually tune, like just slight adjustments. But again, if you have your dead time and lead lag pretty close to the whole situation, that you're like your whole loop, your external loop, like your devices, your latencies and stuff like that, then you should be like right in the ballpark. So just keep that in mind. All right, so with that said, hopefully you learned a lot from this video, and we'll see you guys on the next one.